Let's talk about what a page fault is. So a page fault is when there's some problem in converting a logical address to a physical address. So what could go wrong? Well, let's think of what might go wrong. So it might be that the page table entry is invalid. So the associated page table entry doesn't have the p bit set. And actually the same thing is true on x86 for the page directory entry, right? For the first level page table entry. That's a problem. What will happen? What can the processor do? How does the processor notify anyone of interest that it failed to do this conversion? Well, it causes an exception. In particular, a page fault exception. How would this be handled? Like any other exception, like a divide by zero exception, for example. It would go to a well-known vector of addresses, and it would switch into kernel mode. It would call that address, which then would jump to somewhere else. So jump into the kernel. So the kernel could then do what it wanted with it. And then when it returns, what is key on a page fault exception is it returns to the same instruction that caused the page fault exception, which allows the kernel, interestingly, to set things up to allow the instruction to work this time. So for example, let's say there's a page table entry that doesn't have the p bit set. The page fault exception occurs. It provides the logical address as part of the exception. The operating system can then go and say, oh, I'm going to go ahead and fill in that page table entry, assign some physical memory to it, fill it in, and then it can restart that instruction, and it'll work this time, because when it actually goes to the page table, it'll find there's a valid page table entry there. So that's one cause of a page fault exception. Can we think of another cause? Well, sure. Let's say PTE So PT doesn't have the right bit set, and we're writing. Right? If we're reading and doesn't have the right bit set, that's fine. So that page fault exception. Similarly, if the page directory entry doesn't have the right bit set. What else? Let's see. PTE So the PTE doesn't have a U bit set, that's the user bit, and yet we're in user mode. So if you're in user mode, the only entries that you can access are those that have the U bit set. So if the PTE doesn't have the U bit set, then that's basically an invalid address too. And same thing again for the PTE. So those are the ways in which you can get a page fault. We're going to eventually learn about a lot of tricky things that you can do by writing a particular page fault handler in the kernel. So there's a lot of tricky stuff that one can do, and basically it's the combination of paging hardware and a well-written page fault handler that provides virtual memory.